Your Chapter R exam review packet. At this point, you should know how to do everything, and we are covering right now questions 39 and 40. 37 and 38 were from yesterday, as well as 35 and 36. Notice 35 and 36 simply say state the domain. They don't say simplify. They don't say like add, subtract. You can't add, there's nothing to add or subtract. On this test, I've already double checked the test, went through, changed it. There are 21 questions, which is driving me nuts. I wish it was 20. But I couldn't take a question off because there is literally one question for each topic. Okay, so if you don't know a certain topic, it's only on there one time, except factoring. Factoring is a topic that is embedded within almost half the test because of the simplifying, the multiply, the add, the subtract, the divide, the domain, all of that. Okay, so the test is 21 questions. It is not multiple choice. You're in college. There's no multiple choice. If you have an unexcused absence on the day of the test, you are forfeiting the privilege to take the test. I'll repeat that for dramatic purposes. If you have an unexcused absence on the day of the exam, you get a 0. Here's why. In college, which we are, it's just the high school building, if you don't show up on exam days, they're not going to let you take it later. You cannot expect that same leniency from high school to carry over to college. It does not work that way. Okay? In fact, a friend of mine who works here, when we were talking about this, he said that he got in a wreck on his way to the class, his college class. It was an exam day. He sent a picture of the wreck to his professor at the time, like once 911 had been called. Sent a picture of himself, everything. He had the police report, everything, to prove that it was the exact date, time of when he should have been in there to take the exam. And the professor said, I have another class in 2 hours, you need to be here. And he was in a wreck. Like, it was bad. So to make more money when you come out of it with that paper that says congratulations. But that's part of it, though. And also that's the real world. You know, if you don't show up to work, they're not going to hire you. They're not going to pay you. So keep that in mind. That started because I started to have issues with people not showing up on the day of the exam, and it was never excused. And then the next day they would talk to their friends, find out how the exam went, and then they wanted to be able to take it in a different setting with more time. It does not work that way. That's not fair. I picked up on it real quick. So this is the new policy. Now, if it's an excused absence, then totally. I'm not hanging an excused absence over you. I'm saying if it's unexcused. Okay? Biggest lesson is you just need to do it. Right? Don't push it off. Just do it. Know when the date is. Be ready. Be prepared. Study. Practice. Ask questions. And take it. Alright? So, on the review, the 2 questions that we're fixing to practice are 39 and 40. You can see the level of difficulty here as we look at our notes, and we may have a little bit more challenging questions on there. It's just trying to push you further with your skills. Set penny down. I'm ready to move on. Oh, there she is. I found it. We'll come back to the exam review in a little bit. So for right now, if you'll go to this. Adding and subtracting rational expressions. So before we actually dive into adding and subtracting rational expressions, we need to layer it in 2 ways. First, do you remember a basic adding and subtracting fractions? Second, do you remember how, or do you know how to find the least common denominator? Then we dive into the here's how you add, here's how you subtract. So look at this number 1. I know you might think, well, I'll just type it in the calculator. It's cheating. Let's look at number 1. If we want to add 2/5 plus 7/20, we cannot do that because the denominators do not match, right? That's the 3rd time it's crashed today. I don't know if I need to delete it and reinstall it or what. Okay, so what I was trying to say is you cannot add those because they don't have the same denominator. One's 5, one's 20. So you have to find what's called the LCD, least common denominator. And the beauty of it is if you have just numbers, your calculator will actually do that for you. It's just numbers. Let me find my calculator. There it is. I'll show you how the calculator does it. Again, though, it's only numbers. I wish it worked with variables, but it doesn't. LCD meaning what is the smallest number that both 5 and 20 can divide into nicely? And what is it? 20. Well, they've got to divide into it nicely. They would divide into both of them. So it's always whatever the largest number. It's kind of backwards. The least common denominator is the largest number or higher, if that makes sense. Because the 20's got to be able to go into the 20. So if you go to the math button, go over to number, and they don't say LCD, they say LCM. Not LCD, GCD, sorry, GCD. GCD? I think it's least common multiple. That's factor. Arrow over, it's LCM. 5, 20. There you go. They don't say LCD, they say LCM. You type 5, 20. Yeah. Well, denominator is the bottom of the fraction. Multiple meaning is if you were to sit down and list all the numbers that 5 can multiply to produce, you get 5 times 1, times 2, times 3, times 4. Repeat with 20, you get 20, 40, 60, yeah, sorry. And then it's the smallest number that they both have in common. GCF is the biggest number that will go into both of them. And LCD is the smallest number they both go into. See the direction there? One's a factor, one's a multiple. If that makes sense. And just remember this, it's backwards. Okay? The LCD is the biggest number or higher every time. Because the big number's got to go into itself. So this is the LCD here. The LCD would be 20, which means this one's fine. So we would need 2 over 5 to become something over 20. And the only way to do that, we can't change the value of it, so we're going to change how the value of our 1. We can multiply this by 1, right? Nothing changes. So we're going to change how the 1 looks. If I want 2 over 5 to become something over 20, what does the 5 need to be multiplied by? 4. So to keep it at a 1, it would be 4 over 4. And that would give me 8 over 20 plus 7 over 20, and then I can add to get 15 over 20, which is what? numbers that you have to focus on. I would start with the largest number, because remember I just said the LCD is the biggest number or higher. So start here and just list the multiples. You got 9, 18, 27, 36, and so on. And then which number in there will 4 go into? 4 goes there. Will 3 go into that? Yeah, so your LCD would be 36. Does that make sense? So now we would need to multiply every single one of them by a fancy, unique 1 in order to get 36 in the denominator. Sometimes it's helpful to say to yourself, okay, this is the goal. That's the goal. Now I need to go over there and decide what I'm multiplying by. So if I need 4 to multiply and become 36, it's going to get multiplied by 9 over 9, which is 27 on top. If I need 9 to become 36 by multiplication, it's going to get multiplied by 4 over 4. There's your 20. And if I need 3 to become 36 by multiplication, it would get multiplied by 12 over 12. And then you would finish it, right? Stay with me. Stay with me. You would finish it by just going across the top. You got 27 minus 20, that's 7. Plus 24 is 31, which is prime, so you're done. Ring a bell?
Yes.
Okay. Unfortunately, that's not on your test tomorrow, but the foundation of that is. Now let's just practice stating the LCD when you have polynomial expressions. We are not multiplying, dividing, adding, subtracting. We're not doing anything here. We're just saying what the LCD would be. With me? Okay. Some of these are super complicated, and it's just to see can you find the LCD. I don't want you to actually work with it. All right? Okay, so number 3. We have 3 fractions. Look at the denominators of all 3 of them. Let me show you a technique for finding the LCD with polynomial expressions. It worked with some people don't like it. You decide what you like. Stack them. Stack them vertically. So you have 4x squared. Then you have 2x. Try to stack it where any factor, polynomial factor, is lined up vertically. Okay? And then we have 8x. This is going to help you see that visual. Okay, I've got 4, 2, and 8. And you can work with this. Y'all ever been to an a la carte restaurant? Y'all know what a la carte means? I'm probably saying it wrong because it's country. Yes, if you've ever been to Ruth's Chris Steakhouse, a la carte. If you want sides, that's a side dish that you're paying for. It doesn't come with a meal. So every single plate is an individual price. It's called a la carte. You can work on this in an a la carte fashion. You can focus on just the numbers, get your LCD, then focus on the polynomial expression and get your LCD. So 4, 2, and 8, I said start with the highest number and work from it. Clearly, what's the LCD for the number?
16.
Sometimes the number, sometimes the LCD can be one of the numbers itself. So 8 works. You don't have to jump to 16 because 4 will divide into 8, 2 will divide into 8, 8 divides into 8. So 8 works. Then for the variables, it's always the variable that you see, and then it's the highest exponent. So again, listen to this sentence. It's backwards, meaning it's completely opposite of what you would think. It's counterintuitive. You hear LCD, you need to use the biggest number or higher, and the biggest exponent, okay? So the LCD is 8x squared. Now, come over here and try this one, number 4. Try 4 and 5. 5 should be number 3. I'm sorry. Those should switch, but whatever. The calculator, I don't think it'll do 3 numbers. It didn't. But remember, the trick is go to the highest number and then just start thinking of the multiples of that number. So 8 times 1, 8 times 2, 8 times 3, 8 times 4. And then check which one of those will 4 and 5 go into. And honestly, since 5's in there, that's when I tend to work with 5 because 5 only goes into 0 or 5. You know what I mean? Yes. Yeah, 5 messes it up. All right, so you should have 8xy squared, 5x squared y, 4x. Here's your vertical orientation to help with thinking it through. You got 8, 5, and 4. Did you get 40?
Yeah.
Now you could go to your calculator and just type 2 of the numbers in. You could do 8 and 4, and then 8 and 5, and they won't match. But then you would check the one that would work with the other number that you weren't able to type in. Oh, I'm not done yet. Yeah. I'm not done. All right, so I'm doing the all apart thing. So that's the number. And now we see that we need an x. Take the highest exponent. It's 2. We also need a y. Take the highest exponent. It's 2. Okay? All right. Do we need to work this?
No,
Is it 2?
2x. Now let's get to this. This is more our speed. Stack them. I want you to think of those painted building blocks that kids play with. Would I stack those directly on top of each other? Do they match? No, they don't match. So when I go to stack, I would say I've got x plus 1. I'd come underneath because I'm doing the next one. But I don't have x plus 1 again. Now I have x minus 2. Do you see how I did that? And now it's like you're just coming down and saying, okay, what all did we have? We have an x plus 1 and we have an x minus 2. Look, this Holcombe, they both have x's. Yeah, but they're both attached to plus sign or minus sign, which means it's that painted block. It's an entity that cannot be separated. Okay?
It's like with the ABC problem, the rule of the fractions and how we have to multiply by ABC.
Yes, that's where we're going. Yeah. And I know some people absolutely hate this lesson, but it's one of my favorites, and it's just because once we set it up, things cancel, and then the problem's easy. It's just that first step that's difficult. All right, go to the back. Number 7 is more our level. There's a trick. What's the trick? No, you're not. Are you serious? Ah! What's the trick in number 7? Difference of squares. It's the difference of squares. We can't write our little vertical thing until we have that in factored form, okay? You don't want to go from this to your little vertical orientation and then try to do the LCD. You need it in completely factored form so you can see what are the blocks. So this one's doesn't factor, but this one right here, I would mark out and say to myself, ooh, that's actually this, right? And then now you can go to your vertical orientation. Okay, so we're gonna, and it helps to put parentheses around the polynomial expressions that are multiple terms. So we have x plus 5, we have x minus 5, we have x plus 5, x minus 5. See how I arranged it? Now you're just coming straight down, right? With me? Yes. Okay. I have an x plus 5, and I have an x minus 5. That would take care of the LCD. Now you might say, well, no, wait a minute, it repeated. When you do that vertical orientation, because it repeated, that's letting you know, like, okay, this one matches this one, so you just write it one time. This one matches this one, so you just write it one time. It's only when there's exponents involved, then you have to bring down that biggest exponent as well, okay? So the LCD here would have been that. All right, try 8. So what's in that first fraction that's an issue? There's a x GCF. So write it in factored form. I'm just going to write underneath it. And then this one's fine, and then there's that one right there. And now we set it up. Okay, so my first one is x parentheses x minus 4. My second one matches this one. And you don't even have to write, I'm just trying to show you the vertical orientation. If you're starting to get the pattern here, you could just say, okay, I've got one of those already. It's up to you. And then I have x squared. I'm not going to put that back here. I'm going to come over here and put it right there. And now I'm going to go straight down, take the highest exponent, and that would be the LCD. Now we're ready to add and subtract. You should know that adding and subtracting is the exact same thing. It's just if it's subtracting, there is a little tweak involved, and that's that subtraction sign's an understood -1 that would distribute to things behind it. So that is the difference. If you are adding rational expressions, you will factor completely. I am going to make a note here, if necessary, and actually I'm not going to put it on paper. Technically, you would factor everything completely. If anything cancels, you would let it cancel, then you would go to add or subtract. All of our examples, I'm pretty sure, just involve factor it and focus on the denominator. I don't think that we have any wholes or asymptotes in our adding and subtracting. Just in the multiply, divide, and simplify. Get a common denominator, find the LCD, and create equivalent fractions. And then add or subtract the numerator, keep the denominator. And I am going to put in parentheses, that is the LCD, by the way. You add or subtract the numerator, and you keep the denominator. All right, so what we've been practicing is the very first step. So look at number 9. Come over here to the side and find the LCD. can take too long on this one. What's the LCD?
12X.
It's 12x. So I'm just going to make a note that the LCD is 12x. So I know in my head the goal is to get 12x in the bottom. So this one's already there. This is a problem. This is just how I show my work. I'm going to bring down the one that's done, and I'm going to bring down a fraction and put 12x so I know that that's my goal. Then I'm going to go back up there to that fraction that's an issue and ask myself, focus on the denominator, what would 6 need to multiply by to get 12x? 2x. And that's allowed because I would stick it under a 2x as well. Remember, you can multiply by anything over itself because that's just 1 every time, regardless. Even if it has an x in it, it's still a 1. So across the top, 7x times 2x, 14x squared. Please don't start canceling the x's. I've seen that before. Some people start confusing things that we did with simplifying. They forget the goal was to add, right? I've seen people say, ooh, that cancels. Ooh, that's reduced. Now you're undoing everything you just did. You know what I mean? So remember the goal here is to get that to 1 fraction with the LCD in the bottom. That's the goal. Possibly reduced, but that's the goal. And then across the top, they are not like terms. You write exactly what you see. It would be really nice if you remember to put it in standard form. It is not wrong if you forget, but it's like saying y'all instead of you all. Now, if this was reducible, because we will have some that reduce, I need you to know that it has to be up.
Whoa.
Sorry, I got excited. Wait a minute. It has to be out of all 3 terms if it's going to reduce. And in this case, that 5 is throwing it off. Nothing reduces. Don't reduce the x's because the 5 has no x.
Oh.
It's got to come from everything. Okay? All right, let's look at 10. We're adding, it's already in completely factored form. What's the LCD?
X plus 3x equals 4.
Now in this case, we don't have enough room to show what we're multiplying here, so I'm going to have to rewrite it. So I'm going to bring down the problem, but I know in my head, because I know what I'm doing, it's the same thing every time. I know I'm going to multiply this by binomial over binomial. I already know that. And then I know over here, I'm going to do the same thing. And I'm actually going to highlight this so that you understand that what is in yellow is my fancy ones. And what's in blue was the original problem that has not changed at all. So you can see the word. I just brought the problem down. Okay, so now we have to ask ourselves, what does the fraction not have from the LCD that it needs? This fraction has the x minus 3. It does not have x plus 4, so that's what it needs. This fraction has the x plus 4. It does not have x minus 3. And now you can see why you need to be able to multiply polynomials, because now we have a binomial times binomial, a binomial times binomial, monomial times binomial, binomial times binomial. Good news is, across the bottom is the same thing twice, so please don't multiply it twice, right? Also good news is you could leave the bottom as it is, so that I can see what your LCD was, and you just need to clean the top up, okay? So, fraction, we would have x plus 4, x minus 3 on the bottom. That's our LCD. This is when multiplying, remember me saying this, that I don't like the FOIL method, although there will be times it's really helpful to, you can get there faster. Remember that? This is one of those examples. I don't like the full method because people forget when they can use it. You will be able to use it here because that's a binomial and a binomial. So by all means use it. First, outer, can't do it, but I'll try. Inner, last. Oh, that's ugly. Alright, so we got x squared minus 2x plus 4x minus 8. Keep moving across the problem. Plus, that was a monomial times a binomial, 2x squared minus 6x. Then you would clean the top up. So you'd have 3x squared plus 2 minus, so minus 4x minus 8, right? Right here. That'd be 2x, but then minus 6x. So minus 4x. Yeah. See it now? Negative 2x and negative 6x.
Yeah. 3x negative.
Where? Oh, never mind. Oh, yeah. Thank you. I was trying to find the 4x. Minus 8 over the LCD. Now, technically, you would need to check if your simplified version on top of factor, that's coming down the road. That's not right now. So right now, I would be happy, like this is where I want you to get to. Multiply the top, clean it up, leave the bottom as the LCD so I can see what your LCD was, and you would be done, okay? So there's one of those on the test. And there's one of these. Subtract. It's the exact same thing with one difference. When you go across the top, you would need to remember that's a negative 1 that is multiplying into any polynomial expression after it, which in this case, this particular case, is just positive 3x. So it just becomes minus 3x. But when you get over here, no. Where is it? When you get to this one, that's a binomial there. That subtraction is going to change both of those signs, and that's where people mess up. In fact, let's just jump to 13 so you can see it. Jump to 13, everybody. 13 at the bottom. Yeah, we still have plenty of time. I just want to make sure to hit this one where this is an issue, this subtraction sign. Okay, so first, we can't tell what the LCD is because everything needs to be factored. So factor, please. Now the top, does the top need to be factored?
Not necessarily.
Not necessarily right now. If it said simplify, then you would need to check if anything would clean up. Might not be a bad idea to practice factoring the top, but I need you to find the LCD. You should notice there's a GCF in that top if you are practicing factoring that. And then this is by itself, this is by itself, this factors to that, right? Yep. No, I was showing the GCF in case people needed it. Oh, yeah, if you do that, what's gonna happen is when you set up your parentheses, they both reduce. So even if you miss the initial GCF, which I don't think this one factors. No, it doesn't matter. I don't think that one factors. Factors of 1. Oh, it does, doesn't it? X plus 1, that's a perfect square, isn't it?
Mm-hmm.
X plus 1 and X plus 1. The top one is.
Wait, no. It has to be negative to be perfect square. Wait. I'm confusing myself. Never mind.
You're thinking of difference of squares. We would factor in the top. You don't have to, though. You can. Here's one problem. If I say factor this completely, I would need to see the 3. See how mine shows the 3? If you, if the directions just say, like solve, it was an equation and you were solving, 3 doesn't matter. It would divide away. But if the directions are asking you to just show it to me in simplest factored form, the 3 matters because it's a GCF. So what you would have to recognize is when you go to your parentheses shortcut, right? We said that both of them would have 3x in the front, and then the numbers you came up with, they both reduce. So you would have to recognize if they both reduce, then that actually is a GCF, and you need to write it down. Okay. All right. So stacking our vertical orientation for LCD, we've got x plus 2, x minus 1, then we have x minus 1. So the LCD is x plus 2, x minus 1, right?
Mm-hmm.
Okay, so on the left, does it need anything? No. So I'm just going to bring it down. And I'm actually going to go back to, bless you. I'm going to go back, what was it? 3x squared. You can leave it as 3x squared. I think most people did. I'll show it to you both if you want. Bottom, the goal was x plus 2, x minus 1. Read it carefully, watch. Now what did this one need? X plus 2. Try to change colors. This fraction needed x plus 2. We don't have it yet. Now it has it. Just read it across and write what you see. I see that crap, wrote it. I see a minus, got it. I see x plus 3 in what? In parentheses. And who put the parentheses there? Me. I did that so that I remember, hey, that's coming after a subtraction sign. That's going to actually distribute. Look at the difference if I forget the parentheses. I haven't finished the problem, but look at the difference.
It's just like
It looks like it's just saying minus x plus 3, and that's wrong. So that's why it really helps when you start these problems to group parentheses around those binomials so that if this ends up happening, you'll copy the parentheses and the negative will take care of itself. Now, that is the answer. You have to clean it up. Okay? A couple ways to clean it up here. I first would multiply that, then distribute the negative. So, and this is where I do that work where I showed y'all before. I do an aside, is what I call it, where I just say, hey, this is a lot of stuff in a fraction, and I don't want to keep writing the fraction. So I'm just going to pull that over here, work on it, and then plug it back in, okay? So I'm going to pull this over here to an aside, and I'm going to work on it. Minus parentheses. Multiply that out. I just went ahead. You should get x squared plus 2x plus 3x plus 6. I just went ahead and added the middle terms. Now, see where that negative plays a role? I'm going to bring this this down. Now I'm going to combine like terms, and I actually don't even need to write it here. And now I'm ready to write my answer. Across the top, I would have 2x squared plus x, y'all check me, minus 3. And the bottom, see, when you find the LCD, you've already found half the answer. And I do give partial credit. So it's the top that's the mess. I mess up. When we get to solving equations, yes. For right now, I just need to know, can you add and subtract? Yeah. None of ours, like, because there's only one of each on the test, and I didn't put holes or asymptotes, because I didn't want to, like, just throw you a speed bump from the first exam. But when we solve equations, absolutely it matters. Because the top there, let's see, factors of -6 that add up to, would that keep going? -6 that add up to 1. No, it's got to add +3. So then you got 2x minus 2. And then you got 2x plus 3. Ooh, x minus 1. Ooh.
Uh-oh.
Oh, snap. Look at that. The x minus 1s would cancel in this problem. That's going to bother me now not to finish it. I have to finish it. I'm going to put a dotted line. You don't have, I want to know, can you get here? If you can get here, you're already ready for solving equations. You know what I mean? What I'm about to put. What do we say? X minus 1, 2x plus 3.
Whoa.
Wow, that was really aggressive. I just switched those so that it would be easier to say, whoop, that's gone. So then, I don't like this. I really don't like how that's written. So that's where we're going eventually. Eventually. Like in 3 weeks.
3 weeks? That's not bad.
Oh no. We still have 8 minutes. Yes.
So on the exam, do you want us to receive our answer?
This is the expectation. Yeah. Why don't y'all try this one?
11?
Try 11. Or I can go ahead and give you the practice sheet and we can try number 1 on it. What do you want to do?
Let's do that. Let's get some progress done.
1 through 4 on this practice sheet is just tell me the LCD, and then the rest of them are, hey, now add and subtract, okay? Please remember that there is only 1 addition, 1 subtraction on the test. There's not a single, what is the LCD? Because you should be able to do that when you add or subtract. So please don't spend your entire night focused on 1 problem on the test. You know what I mean? If there's other stuff you're struggling in, divide your time up and focus on it too, because there's only 2 questions on the test out of 21 from this sheet. You with me? If, I know how some people are, if anyone wants extra questions to practice, I'll let you grab it as you're leaving. It's going to be right here. It is not a grade. You can tell which one's the grade, the one that matches the same formatting. This was just if you wanted extra practice, and I can message you the answer key. That's up to you. This would be extra practice in domain, multiply, divide, add, subtract, factoring. Please don't forget to do the review packet if you have not finished it. The answers are posted. I'll shift it to the top in Google Classroom so you don't have to search for it. It is not a grade because the answers are posted. That review packet, yeah. No, because I gave you the answers.
So all of the full pages of the correction line.
No, I'm gonna take a grade. I'm not gonna, hey y'all listen, I'm not gonna take a grade on this practice assignment. How about this, Brody? Do Friday. I do need to take a grade on it. Do Friday. Does that work? That way,
Just because I just studied.
because I'd rather you study than worry about a single homework grade. But I need you to do this. 14 problems. in the
Yes,
first-
Falcon.
Alright, I won't take it.
That's 14 times 2.
That help? Are you stressing out? I can't read you very
Nah,
well.
I'm good. Definitely.
Sure.
I'm good. It's 7 times 2.
Yes. Yeah, and it's rewrite it. No, this is just saying write it in exponential form, so this is right.
Because it's outside of the
Oh, it's the same thing. The property in exponents, whatever's on the outside can come up there as well. During the
That's what I'm saying.
This Holcombe.
It's about Friday.
Yeah.
What about Thursday?
Tomorrow. I think.
Hey guys, can you look at number 12 real quick? Because it doesn't happen on this test, but it will happen soon. So it's a great preview of what's to come. I won't dive into it too deep since it's not going to be on the test. But what do you notice about the denominator here?
It's flip. It's a negative edge.
So if you go to stack it, if you stack it, I'm going to actually stack it vertical because I want you to see something. They're just completely switched and the signs are switched, right? So I can take this and I can pull a negative out and then I end up with that. You see it? So you would just need to account for the negative in this case, which means it's no longer a subtraction problem because it would come out of this one. It would now be a addition problem, and this would be x minus 3. I know, it's like magic. Don't worry about it for the test. When it happens again in the actual content, I'll say, here we go. There's a negative trick here.
So this whole
We do it all on a grade by Friday.
In here.
that would be weird.
I will, how about I will,
You should give us a treat. We've done so good.
how about extra credit?
extra
How about
credit.
donuts?
Extra credit.
Extra credit.
Donuts?